KeyChannel.com. Today I'm going to introduce you to the P3 kilowatt voltage usage monitor. And what this is, it's a little meter that you plug into any receptacle in your house, and it will analyze the receptacle for you. Right now it's showing how many hertz is coming into the receptacle. Hertz is cycles per second of alternating current. And you press the volt button right here, and you got 118.2 volts currently coming into this receptacle. So that's one thing you can do with this P3 kilowatt electricity usage monitor. The other thing you can do is you can come up with strategies where you could save money. For instance, this little monitor will tell you the efficiency of different appliances, and it can be used best when comparing like appliances. Perhaps if you got two 1/2 inch drills, you can plug them in here and you can compare what's called the power factor. This little button right here says PF. That's power factor, and the closer the power factor is to 1, the more efficient that electric motor is. So, and you could then select the one that's more efficient and use it, and maybe save a little money. That's one example. So it's both for analyzing receptacles and for saving money on your appliances. First thing I'd like to do is go over the different functions of the meter, and to help me show you, I'm going to plug in this little coffee grinder. You can plug in any appliance you want into it, and I'll be able to, just turn on the coffee grinder and show you what happens. Now that I have the coffee grinder plugged into the kilowatt, I'd like to discuss what the different buttons are and what they mean. The first one on the left is volts. Volts is potential energy, and on the screen right now you see it's showing 118.9 volts. You're not being charged for this right now because nothing's running. It's just potential energy. It's ready. Whenever you plug something into it and turn it on, then you'll have what's called amperage. And then you're drawing electricity, and you are being charged for it then. But voltage is only potential energy. The next button right here, once we're pressed, you see it's going to be 0 because we're not using anything right now. The little coffee grinder is plugged in, but it's not on. Now if I turn it on, you see it draws a little amperage, maybe 0.4 amps. It's just a very small appliance, but that shows you you're then being charged for the electricity. And you can see how many amps it draws. Now if you're having a problem with blowing circuits, you can go around and check how many amps the different appliances are using, and you can take one of the larger ones off of that circuit and put on a different circuit, and that should help you to not have circuits blowing. Of course, the ultimate fix would be to add another circuit, but it's more of a temporary fix. You just take something off of that circuit and plug it into a receptacle belonging to another circuit. And so this meter helps you determine what's using all the electricity, what's using all the amperage. This next button right here is a toggle button. It has watts if you press it once, and volt amps if you press it twice. Watts is what we call active power. It's what you're actually charged for as watts. Volt amps is what the utility supplies to your receptacle, and it's your input into a motor, a little thing like I got this a coffee grinder here. If we press watt, we see we press the. Okay, we're using 48. Okay, we're using about 48 watts. Alright, so let's do it again and get the volt amps. Okay, we're using about 49 volt amps. So we're using, for the same appliance, we're using 48 watts but 49 volt amps. So this is the apparent power. Volt amps is what we call apparent power. Watts is what we call active power. Watts is what's actually used. In a typical motor, you will find capacitors and inductors, and that creates an inefficiency. The inefficiency, it can be found over here in power factor. So I could compare different coffee grinders and figure out which one is the most efficient, because the power factor will be closer to 1 on the most efficient one. Okay, let's turn it on again and we'll get the power factor. Okay, first I'm going to press Hertz at 60 Hertz. Now I'm going to press power factor. Okay, 0.98, 0.99, 0.98. Alright, so that's pretty close to 1. So it's a pretty darn efficient little coffee grinder. Now with the coffee grinder off, the power factor is 1. So there's PF right here, 1. So it's always going to say 1 when nothing's going. But you saw the watts is a little lower number than the volt amps. So a power factor is watts divided by volt amps, and that came out to 0.98. So it's a pretty darn efficient coffee grinder. Hertz is cycles per second. That's your alternating current coming into the house, and it has 60 cycles per second in the United States. In Europe, it's 50 cycles per second. Now we're going to discuss kilowatt hour. Now, since I've had this plugged in, I've used all I've done is use a little bit of the coffee grinder. So kilowatt per hour, probably 0. It is. I've had this plugged in for 57 minutes. It gives you kilowatts per hour, which will be a number showing you how much electricity you've used. The little coffee grinder uses so little that it's still 0. And then the last button is just time. Now it's been plugged in for 58 minutes. Okay, I have unplugged the little coffee grinder and I've plugged in a toaster oven. So we have 118.9 or so volts, 118.7 volts coming into the receptacle. Now watch what happens when I flip on the toaster oven and turn it to broil. Okay, it just turned on and there it is. It went from 118.7 to 116.8. So we lost 2 volts. Now let's see how much amperage the toaster oven is using. It is 6.83 amps. Okay, so that's a lot. You see the little coffee grinder only used about 0.4 amps. So now we're starting to use some electricity. If you have a 20 amp circuit, this is using about 7 of the amps. So if you have a situation where your circuit is blowing, you might want to put the toaster oven on a different circuit. Okay, so let's find out what the volt amps is and what the watts are. Now it's going to be quite different because this is what is called a resistive circuit. Any kind of heating circuit uses semiconductors, which are basically resistors. They heat up and they cause the food to heat up, but there's no capacitors or inductors. So this should be, the power factor should be 1. We'll see. We'll put it on watts. We're using 799 watts. So you figure an LED light bulb today uses about 8 watts. This uses 799 watts. Okay, let's see what the volt amps is. It should be the same thing. It is. Same thing. Because this is a resistive circuit. It doesn't have inductors or capacitors. So Hertz is 60, and let's find out what the power factor is. Power factor is 1. So you got a perfect power factor, but that's what you have to expect with a heating element. Your power factor should always be 1 with a heating element. If it's not, that would indicate a problem. Alright, so let's find out what we're using in kilowatt hours. It'd be 0.06 kilowatt hours. So we are starting to get charged for electricity now, and the time elapsed is 1 hour and 10 minutes. So that gives you an example of what your kilowatt meter is going to show you with a heating element like a toaster oven. Now I have unplugged the toaster oven from the kilowatt meter, and I've plugged in my Vitamix blender. If you've ever seen a Vitamix blender, they have big motors. You can see right away the voltage has popped back up to 119.3. And you saw when I plugged in the toaster oven, we had a voltage drop of just about 2 volts. So the first thing I want to show you is if there's a voltage drop using the big motor. And I'm going to go ahead and turn it on. Turn it on low first. Okay, that's just low. There's no, well, a little bit of voltage drop. And turn it up. Okay, we had a voltage drop of about 1 volt, turning up the Vitamix blender all the way. So let's find out how many amps the blender uses now. Turn back on. Okay, what you saw right there is amperage at startup was 4, and amperage once it got going was about 3.8. That's a good thing to point out, because amperage at startup is always higher. That's why people blow the circuits most often when they first turn on an electric appliance, a bigger electric appliance. Like you first turn on your microwave, boom, that circuit, you know, if it's on a circuit with something else, the circuit's going to blow. If it's going to blow right there at startup. See, the startup amperage usage is a little higher. This blender uses about 3.8 amps. So let's find out what the wattage usage is and what the volt amps usage is. And since this is a motor and it does have capacitors and inductors, we should have a difference. Again, the volt amps is the apparent power. The watts is the actual power. The apparent power is what's coming into the unit from the supply. The watts is what's being actually used, and there should be a little difference, and the difference is going to be indicated by power factor. So let's find out what it is. Okay, sorry about the noise there. So you saw the watts was a little lower than the volt amps, and the power factor was about 0.98. It read 0.97 for a while and then 0.98. That shows you it has a high efficiency, just about the same as the coffee grinder. Of course, it's not going to be as good as the toaster oven, because that's what they call a resistive circuit with resistors, as opposed to capacitors and inductors that you find in a motor. And you saw the hertz was 60. So the power factor for both the grinder and the blender was about 0.98. And now we can see what we use for kilowatt hours. Okay, we're up to 0.07 kilowatt hours, and the time elapsed is 1 hour 21 minutes. Now I've plugged in a 75-foot extension cord into the receptacle and into the extension cord I have plugged the kilowatt meter, and into the meter I have plugged the Vitamix blender. This is to show the effect of voltage drop, and I've added a 75-foot extension cord. This adds resistance to the line, and there's more resistance for the potential energy that's in the form of voltage that's getting to the motor. The motor is in the form of the Vitamix. So I'm going to demonstrate now what happens when you add this 75-foot extension cord. So I'm going to go ahead. It's at 119.3 volts right now, and that's even, you see, that's even at the end of a 75-foot extension cord. So there's not a lot of voltage drop shown without the load, but once you put the load on it, I'm going to show you what happens. To sum up, I hope I've shed some light on what the different functions of this meter are, and perhaps how you could use it to analyze an electrical receptacle, and how to analyze an appliance, and perhaps you'll be able to pick an appliance that is more economical. Perhaps two different appliances do the same thing, but one of them uses quite a few more kilowatts per hour than the other. A good example of that would be an air conditioner. You could test out two air conditioners and perhaps give yourself a good savings by choosing the one that is more efficient. Also, I hope I shed some light on how to deal with voltage drop. It's a really important subject, especially when you're using long, skinny extension cords out in the yard with electric lawnmowers and weed whackers and so forth. If you're only getting 115 volts to that electric motor, it's going to be hard on the motor. The motor's not going to last as long. It's not going to work as well with only 115 volts. So if you can use a bigger gauge extension cord and use the shortest one you can, you'll extend the life of your electrical lawn care devices. In my video description, I'll put a link for the P3 kilowatt electricity usage monitor. I'll put a link for the P3 International Kilowatt EZ electricity usage monitor, which calculates costs by month, week, and year. I'll put a link for the P3 P4480 kilowatt electricity usage monitor with electronic graphic timer. And last but not least, I'll put a link for the Vitamix Professional Series blender that you saw in the video. I hope this video was of help. Thanks. Channel.com. Today I'm going to introduce you to the P3 kilowatt voltage usage monitor. And what this is, it's a little meter that you plug into any receptacle in your house, and it will analyze the receptacle for you. Right now it's showing how many hertz is coming into the receptacle. A hertz is cycles per second of alternating current. And you press the volt button right here, and you got 118.2 volts currently coming into this receptacle. So that's one thing you can do with this P3 kilowatt electricity usage monitor. The other thing you can do is you can come up with strategies where you could save money. For instance, this little monitor will tell you the efficiency of different appliances, and it can be used best when comparing like appliances. Perhaps if you got 2 1/2-inch drills, you can plug them in here and you can compare what's called the power factor. This little button right here says PF. That's power factor, and the closer the power factor is to 1, the more efficient that electric motor is. So, and you could then select the one that's more efficient and use it, and maybe save a little money. That's one example. So it's both for analyzing receptacles and for saving money on your appliances. First thing I'd like to do is go over the different functions of the meter, and to help me show you, I'm going to plug in this little coffee grinder. You can plug any appliance you want into it, and